Section 2.5 is about variation. We are going to look at 4 different types of variation, and then after that, we're going to look at some examples and go through the steps. So the first type of variation that we're going to talk about is direct variation. And you'll recognize it because it might say y varies directly either with x or as x. But these will be like other things, like the amount of money I pay at the gas station varies directly with the number of gallons of gas I purchase. Or it might say y is proportional to or directly proportional to x. And the way that we're going to set up these problems, the formula that we'll follow is y equals k times x. So with direct variation, the two variables are directly across the equal sign from each other. So this is our first variation equation. Now this letter k that's in there is going to be in every single variation equation we set up. It's called the coefficient of variation. So when we start setting up each equation, it's always going to have that letter K in it. And like in my gas station example, where the amount of money I pay at the gas station varies directly with the number of gallons of gas I buy, then this value for K would be how much I pay per gallon. So if I said I spent $20 when I went to the gas station and I got 10.432 gallons of gas, then when I solve for K, I would get how much money per gallon the gas cost me. The next type we're going to look at is inverse or indirect variation. Excuse me. So you'll recognize that because it will say y varies inversely or indirectly with or as x, or y is inversely proportional to x. And the formula for that is y equals k divided by x. So this is the format that I use, y equals k divided by x. You could also see it written as y equals k times 1 over x. So I think of indirect, like remember direct was directly across the equal sign. Indirect, the variable goes in the denominator. So whenever we see the word indirect, that next variable is going to go into the denominator or inversely. So y varies inversely, the x goes in the denominator. The next one is joint variation. And joint variation is similar to direct, but it has more than one variable that it's going to vary with. So when it says y varies jointly with, like together at the same time, jointly as or with x and w, for example, then our formula would be y equals k times x times w. So you just have more than one variable. And then the last one we're going to talk about is combined variation. And that's where you're going to have more than one type of variation in your problem. And those are actually pretty common. So here's an example of one that you might see. Y varies jointly as x and z, and inversely as the square of w. So we're going to look for those key words, jointly, direct, indirect, inversely, all those words that we talked about up here already. So when we write our formula, it's going to be y equals, we're going to keep the k either in the numerator or out front of our fraction. Anything that says either direct or joint is going to go in the numerator, and anything that's either indirect or inversely is going to go in the denominator. So that's the general layout of our formula. Let's get to this specific example we had over here. Y varies jointly as x and z, so y equals k times, jointly as in the numerator, x times z, and inversely as the square of w. You're going to want to watch those. The square of w is w squared, not the square root of w. So watch out for that because it gets people frequently. Or we could write it y equals k times x times z over w squared. Okay, there are 3 levels of problems that you will be asked to do with these variation problems. Level 1 is just to set up the variation equation with all variables. So similar to what we have up at the top here, there's no numbers in there, other than the squared. It's just going to be all variables. And the thing is, you have to do a level 1 question, like you have to do level 1 in order to move on to level 2. You have to do level 2 to move on to level 3. So if you have a level 3 problem, you're going to have to do the first 2 levels anyway to get there. So that's level 1. Level 2, then we're going to go a step further. We're going to do number 1. Then we're going to sub in one set of known values to find k. Then we rewrite the equation from step number 1 with the value of k. No other numbers, just plug k back in there. So this first step would be like the writing the variation equation. Then this would be like the general variation equation, find k and then write it in there. Replace the k with the number you got. And then a level 3 is we have to do number 1 and number 2. Do those first 2 steps, but then use a different set of values that's missing 1 to find an unknown. So we're going to look at examples of all of that. In this first example, I've separated the words out into the 3 levels so that you could see how they're going to be written when you go to do a problem. So level 1, we just write the variation equation. So we're looking for the keywords. So A is proportional to, that's a direct proportion. It doesn't say direct, but that's how it's phrased, to the square of t, and then we have inversely proportional to the cube of x. So our variation equation, level 1, is going to be A equals, we always have k times, so k times square of t is going to be numerator. This is actually a jointly inverse. And inversely goes in the, joint variation. The proportional one goes in the numerator. The inversely goes in the denominator. So proportional to the square of t, we'll have t squared in the numerator, inversely proportional to the cube of x. So x cubed goes in the denominator. And that's it. Like, that's the equation. That's the entire answer for a level 1 question. Then in level 2, they're going to go a step further and give you a complete set of information so that you can solve for k. So you say when t is 4 and x is 5, a is 32 over 125. So we just plug those in. So a gets 32 over 125. We don't know what k is. T is 4, so 4 squared, and x is 5, so 5 cubed. Okay. So that gives us 32 equals k, well, 32 over 125 equals k times 16 over 125. So then if we multiply both sides by the reciprocal here, 125 over 16, then the 125s cancel to leave us 1. The 16s cancel to leave us 1. So that's going to give us k over on this side equals, these 125s cancel to 1. And then the 16 and 32 leave us with a 2. So when we multiply those, we get 2 over 1. So k would equal 2. So if they just ask you to find the constant of proportionality, we would be done, or the coefficient of variation. Then if they're wanting us to find the equation for the variation or find the variation equation, we're going to rewrite what we had in step 1, but we're going to replace that letter k with a 2. But we leave everything else variables. So level 1, this is what your answers will look like. Level 2, this is what your answers will look like. Level 3, then they ask you to find something. So level 3, find the value of a. So now we don't know what a is. So we go back to our formula from level 2. A, which is 7. So no, a is what we're finding. My apologies. A, which we don't know, equals 2 times x is 7, t is 3. So we got x is 7, t is 3. So then that would be a equals 2 times 9 over 343, which we would multiply straight across over 1, 18 over 343. So finding the value of a equals 18 over 343. And that's what a level 3 type of answer looks like. We got some more examples. Sometimes your questions are not contextual, like this one. It just gave us numbers and words, but no context, like it wasn't about a gas station or anything. Sometimes they give you context to your question. So this one is going to be contextual. Our payment P varies directly with the amount borrowed B. The monthly payment on a 15-year mortgage is $8.99 for each $1,000 borrowed. Find the monthly payment when the amount borrowed is $175,000. Okay. So all 3 of our levels are in here. So it's actually like they're asking you for a level 3 answer, but remember we have to do the first 2 levels first. So this part here is our level 1 information. The payment P varies directly with the amount borrowed B. So level 1, P varies directly with, so equals K times B, the amount borrowed. Then in the next step, level 2, they're going to give you everything you need to know to solve for K. So then they tell us the monthly payment on a 15-year mortgage is $8.99 for each $1,000 borrowed. So payment was P, so this is P, and the amount borrowed was B, so this is B. So in our formula, we'll go P, which was 8.99, equals K times B, which was 1,000. Then we solve for K, divide both sides by 1,000, which means I need to move my decimal place over 3 times. 1, 2, 3. So 0.00899 would be K. And then for my answer, I'm going to replace that K with what I just got. So P equals 0.00899B. I know when you're working on your own, like on your practice problems, it's very easy to not be organized in your work and to skip writing these steps out. If you get into that habit, then what's going to happen is when you take your quiz or test, you're not going to write out all those steps and you're going to miss points because whoever is grading your test, which is probably going to be me, is looking for all of these pieces along the way. Then level 3, they're going to ask you to find something, find the monthly payment, and then they're going to give you information when the amount borrowed is $175,000. So if I were to take out a $175,000 loan, mortgage, how much would my monthly payment be? So P is the thing we're looking for. P equals K is this 0.00899, and then times B, which was 175,000. Yikes. Let me grab a calculator. So 0.00899 times 175,000. So 1573.25. So that would be, in context, it has money, 1,573.25 would be my mortgage payment. Okay, next little guy. The time it takes to get to school varies inversely with the average speed. So T is the time it takes me to get to school. Average speed is S. If it takes you 40 minutes to get to school when the average speed is 30 miles per hour, write an equation. So here we've got level 1 right here, level 2 right there. Suppose your speed is 40 miles per hour. How long should it take you to get to school? That is a level 3. So in level 1, we're just writing the variation equation. T varies inversely with S. So T equals, inversely is over S, or T equals K times 1 over S. But I needed that information before I could answer part A, that they're asking me for a level 2 question. It takes you 40 minutes to get to school when the average speed is 30 miles per hour. So 40 minutes equals K over 30 miles per hour. Of course, multiply both sides by 30. And that's going to give us K equals 1,200. But that's not the answer they're looking for. They want us to put the equation back. T equals K over S. So T equals 1,200 over S. Then level 3, they give us other information. Suppose your speed is 40 miles per hour. How long should it take you to get to school? So T is what we don't know, but we have our formula. T equals 1,200 over S. Speed is 40. And then we simplify that. So it's 120 divided by 4. So T would be 30. So in context, it would take me 30 minutes. Now, if you wanted to, you could convert your minutes into hours, and then your answer at the end here would be hours. But since we used minutes in our original formula, the answer at the end is also going to be in minutes. So it's kind of handy. Force on a plane surface by wind F varies jointly with the area of the surface and the square of the velocity of the wind. If the force on an area of 20 square feet is 11 pounds, when wind velocity is 22 miles per hour, find the force on a surface area of 47.125 square feet when wind velocity is 36.5 miles per hour. So we got to work through this, figure out our level 1, 2, and 3. So level 1 just tells us the relationships that are going on. So we've got the force on a plane surface by wind F. So F varies jointly with the area and square of the velocity of the wind, W. So that's our level 1. So force varies jointly means they're both multiplied in the numerator. So K times area of the surface of the plane, I guess, and square of the velocity of the wind, W squared. Don't miss out that square of that will mess you up because then you won't be using the right formula and you'll get a wrong answer. So here we have force equals K times A times W squared. It's level 1. Level 2, then they're going to give us a complete set of information. So we'll have to know force, area, and wind so that we can solve for K. So force on an area of 20 square feet is 11 pounds when wind velocity is 22 miles per hour. So force is 11 pounds. 11 pounds equals K times area is 20 and velocity is 22, so 22 squared. So 20 times 22 squared is 9,680. So 11 equals K times 9,680. So then K would be 11 over 9,680. Let's see if that simplifies. Yes. So K equals 1 over 880. So in my level 2 question, I'm going to rewrite this formula, but use 1 over 880 for K times A W squared. If I wanted to, I could rewrite it as F equals A W squared over 880, by multiplying my fraction straight across. But that is going to be up to you, whichever way you prefer that. And then level 3 wants us to find the force. The force is with you. F is the thing we don't know. Surface area is 47.125. Wind velocity is 36.5. So going back to this formula, force equals 1 over 880 times A, which was 47.125, times W squared, so 36.5 squared. And then this is just a calculator problem. So 36.5 squared times 47.125. And then that's this multiplying by 1 over 880 is the same as dividing by 880. So I'm getting 71.34350142. And then depending on what they ask us to round to, we'll round appropriately. I'm going to say let's round to the nearest thousandth. The thousandths place is 3 decimal places, so that's equivalent ways of saying the same thing. So we'll go 71.34, and then the thousandths place is right here. So we go tenths, hundredths, thousandths. We look to the right. If that number is 5 or higher, we bump this up. If not, we leave it alone. So 71.344 is what it will end up with. And the units for force was pounds. So at the end of all of this, the answer they were looking for was this. But we had to do all those other steps along the way. Resistance of a wire. Okay, so here we go. The electrical resistance of a wire R varies directly with the length of the wire, L, and inversely with the square of the diameter, D, of the wire. If a wire 432 feet long and 4 millimeters in diameter has a resistance of 1.24 ohms, find the length of a wire of the same material whose resistance is 1.44 ohms and whose diameter is 3 millimeters. Okay, so level 1, we have to write our proportional, or our variation equation. So the resistance of a wire R varies directly with length of the wire L inversely with square of the diameter D. So R equals varies directly with, so K times L varies inversely with the square of the diameter, so D squared. And then level 2, they're going to have to give us a resistance, a length, and a diameter so that we can solve for K. Level 2. A wire 432 feet long, 4 millimeters in diameter, resistance of 1.24 ohms. So resistance, 1.24. K, we don't know. L was 432 feet. And diameter was 4, but it's 4 squared. So 1.24 equals K. Well, I guess we could write 432 K over 16. Let's see if 432 divides 16 evenly. It does. So we got 1.24 equals 27K. So then K will be 1.24 divided by 27. I'm just going to leave it in that fraction. So my level 2 would be R equals 1.24 over 27 times L over D squared. Or we could write it, if we multiply straight across, 1.27 L over 27 D squared. Then level 3, they're going to ask us to find something. Find the length of the wire. So that's what we don't know. Of the same material whose resistance is 1.44 ohms and whose diameter is 3 millimeters. So the L is what we don't know. We know R, 1.44, equals, so I'm going to use this format right there. 1.27 times L, which is what we don't know, divided by 27 times D squared. D was 3. And then we'll clean that up a bit. 27 times 9. So we have 1.44 equals 1.27 L divided by 243. So then we could multiply both sides by 243, which lets us get rid of that denominator. So times 1.44. So 349.92 equals 1.27 L. Divide both sides by 1.27. Oh, I wrote that down wrong, didn't I? Whoops. I bet you guys were like, what are you doing? That's a 4. Sorry about that. So now let's divide both sides by 1.24. Okay. So 349.92 divided by 1.24. So L would be 282.1935484. We'll just go with that same rounding that we had in the previous problem. So we'll go to the thousandths, which is 3 decimal places. So we go tenths, hundredths, thousandths. Look to the right. That is fewer than 5, so we do not round the 3 up. So we would have 282 point. Oh, I went to the wrong decimal. Y'all, Okay, I'm rounding from the 3 and I have to look at the 5. So here's my thousandths, tenths, hundredth, thousandths, look over. That is 5 or more, so I bump up the 3 to a 4. So 282.194, and the units for the length of the wire were feet. Okay, so I guess bottom line, be careful with your math, because as you've seen, it's pretty easy to make mistakes.